Hi, everybody. My name is Rachel Anderson. I am really excited to be hosting, being one of the hosts, many hosts for this online conference in 2025. Before we get too started into it, I wanted to share just a little bit about me. I am a homeschooling mom. I have 4 kids, and I have homeschooled 3 of them all the way through to graduation. I'm finishing up my 4th daughter at this point, so she's got another couple years before she graduates. I have taught RightStart Math for 16 years, so I love the program. I love seeing my adult children engage in math outside of classroom and seeing how far they've progressed and how they influence their peers even in the adult world. But enough about me. I am totally excited to share with you about Dr. Cotter's new book. And I get to share, by the way, she's on with us. So if you have any questions, hang on to those or put them in the chat. Also, feel free to keep your microphone on mute and just put information on the chat and we will collect those. But at the very end of this workshop, if you have a question, Dr. Cotter is going to be on with us and you can ask her directly. So a great opportunity. I am fortunate to be sharing with you the chapters on addition and subtraction. Now, this is from Dr. Cotter's upcoming book called Start Math Right, The Journey to Mathematics Excellence. And a lot of what she's pulling in the book is the reason why RightStart Math is so effective, right? So I'm going to share a little bit about what's going on in the chapters of addition and subtraction. Most of what my time is going to be focusing on addition. But at the end, we'll cover some topics for our subtraction. Dr. Cotter writes in her book, adding is the most fundamental of arithmetic processes. It is so much a part of our culture that it's not unusual to hear tykes exclaim, 2 plus 2 is 4, without a bit of understanding about what they are saying. And that is one thing I absolutely love about using RightStart Math to teach kids, is that the focus is on understanding, not just memorizing words and symbols. Now, how is that done? Well, when I first started teaching RightStart Math, I was really blown away by the process of teaching kids to add, starting with what the child already knows. Now, if you attended the number sense session with Debbie, you learned a little bit about subitizing. We start with what the child knows. Show me 1, right? Show me 2, show me 3. Children know how to do that, right? They don't have to count, although we try to make them count. But honestly, if we were to show them this, they would say, oh, that's 3 without counting. So Dr. Cotter takes that model, that understanding, and gives it a brand new look through the Cotter abacus. So what she asks in the lessons is, show me 1 finger. Now show me 1 bead on the abacus. Show me 2. Show me 2 beads on the abacus. Show me 3. Show me 3 beads on the abacus. And by the way, I'm going to talk about this in just a little bit. And look here, you can see 5 and 5. It's really tiny, but if you can see that 5 and 5, it mimics our hands, right? By working through such basic activities such as this, children learn that numbers are quantities. They're not the words. They're not even the symbols. It's the quantity. So without this fundamental understanding, symbols do not make sense to the child. The point is that symbols are the written form of quantities. If the child does not have this understanding, they're required to memorize symbol plus symbol equals another symbol, or word plus word is another word. That's a language skill. However, when we incorporate the Cotter abacus and the skill of subitizing, children quickly solve, understand, and learn their math facts. Let me show you how that works. Here we're given the equation 3 plus 2. Notice it's in the symbolic form, in the number symbols, right? Now we are going to take the child through that symbolic element and bring it down into what I call the concrete realm, the real meaning of what a number is. So we start with this. What is 3? Well, 3 is this. 3 is a quantity. Okay, show that on the abacus. What is this symbol representing? It's add, it's bringing to. What does it mean? It adds more to it. Okay, so what's this symbol mean? 2. All right, show me what 2 looks like. There's 2. Now we're going to slide them all together because we're adding them together. How many beads do you see there? Notice I said, how many is there? 5. It mimics our hands. 5 and 5. We see 5. Great. Now, how do you write 5? This is how we write it. By doing this activity, your child sees the abstract symbol, gives it meaning, sees the answer, and then writes the solution in the symbol, the abstract form again. Right? Do you see this difference between teaching basic addition math facts this way versus the traditional way that both you and I learned, right? When using the Cotter abacus, children understand what 3 is. They understand what 2 is. They understand the plus sign, the equal sign. It's not just about memorization. And children can also visualize the process in their mind. Dr. Cotter wrote in her book, notice that no counting is ever needed. The sum can be simply recognized through subitizing. Now, I have 2 children in my home. If you've heard me speak before, they have learning differences. One of them has working memory deficit to the degree when he was very little, he could not memorize. How do you teach math if you can't memorize? Well, do you know he was able to solve, answer math facts, get this, more accurately and quicker than his kindergarten and first grade peers? How is that possible? Well, if I were to say what 3 plus 2 is to my son, he would picture the abacus 3, 2, 5 and gave me the answer. He was visualizing it in his mind. Whereas his peers, if I were to say what is 3 plus 2, they're going 3. 1, 2, 3 plus 2. 5. You see the difference? Sometimes they didn't even count accurately. All right, so that's basic math facts, right? What about a little bit bigger facts? Say facts equaling 10. Dr. Cotter writes, the facts that equal 10 are the most important facts for children to learn. And she has the children work on the abacus. This is a picture of what we call building stairs. And you can kind of see why it's called that. You know, it kind of looks like a little staircase, right? Climbing up. But we actually start from the top. But she also calls this counting with meaning. We slide 1 bead over, 2 beads over, 3 beads. Why does she call it counting with meaning? Because kids are taught from the first time they can speak to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are just words that they're trying to remember the order of. It doesn't make any sense to them. However, when we're putting it on the abacus, 1, that is what 1 is. 2, that is what 2 is. 3, 4, and so forth, right? Now, how does this affect facts that equal 10? What does that have to do with anything? Well, take a look. If I slide 1 bead over here, how many beads are on this side? Do you see the 9? We see 5 and 4 more, 9. What about 4? 4 and 6 equal 10. So simply by moving beads over on the abacus, the kids are learning their facts of 10 without even realizing it. The Cotter abacus is a great tool to show partitioning. Now, if you are not familiar with partitioning, it is basically splitting a quantity into sections, right? And in this case, it's into 2 parts. Now, I'm going to take a look at that abacus and see 4 and 6 is 10. That's partitioning 10 into 4 and 6. Now, one of the most fun and unique aspects to RightStart Math are the math card games. After a child has been introduced to a concept, Dr. Cotter has them play a math card game that will help their child further learn, explore, and practice it. So we just talked about the math facts of 10, right? Dr. Cotter then has them play and practice a game working on those math facts of 10, and it's called Go to the Dump. Just real quick, this is a freebie, by the way. So you get to go home this afternoon and play this game with your kiddos. Basically, Go to the Dump is go fish. But instead of asking for the same card that I have, for example, if I have my hand full and I have a 2 in the traditional Go Fish game, I'm going to ask for a 2. But not in this version. In this version, you're going to ask for pairs that total 10. So if I have a 2 in my hand, what do I need to add to 2 to get to 10? I need 8. So I'm going to ask for an 8. And the good news is you only need basic number cards, 1 through 9. And that's all you need to play this game to help your child learn the facts of 10. Speaking of learning the facts, when I play Go to the Dump or pretty much any math card game with my kids, they become more and more fluent with the facts without flashcards, without worksheets, without time tests. Yes, RightStart Math has worksheets, but they are not needed to learn the facts. Okay, that brings up a question that I'm pretty sure you guys are already thinking in your head. What is fluency then? How do I know if my child has their math facts learned? Dr. Cotter writes in the book about a problem that's occurring in math today. She says, teachers and parents often want their children to know their facts so well that they can regurgitate them instantly. Now, this is a huge pet peeve of mine. Why is it that we expect our children to know their math facts so quickly, immediately, when in any other subject, we allow them time to figure it out? For example, if I'm in spelling class and I ask my child to spell vocabulary, what do? Vocabulary, V-O-C, V-O-C-A-B-U L-A. See what I'm doing? We're giving our kids time to think about how to spell that word. But in math, if I ask what is 2 plus 3 and they are not immediately saying 5, I say, oh, we need more practice, right? Don't we do that? Dr. Cotter often uses the statement from the National Council of Teachers of Mathematics, also known as NCTM, abbreviated, who say that a math fact is fluent if the student can answer it in 2 to 3 seconds. Now, this allows the child to think about the process, to use strategies to find the answer. That is how they learn the facts. But traditional approach to learning math facts involved rote memorization almost exclusively. And in an attempt to accomplish this rote memorization feat, children are subjected to flashcards, numerous worksheets, timed tests. Dr. Cotter writes, these methods discourage thinking. Research shows that a different part of the brain is involved in rote memory compared to mathematical thinking. When memorizing facts through rote methods, the student is using the language part of their brain, either connecting together words, 2 plus 2 is 4, or seeing the symbols work together. These both are language skills. However, when the student works with quantities, are given strategies to think about math, they are using the math part of the brain. Now, I must admit, I've got a confession here. In elementary school, I loved flashcards and I loved worksheets and I loved time tests. You know why? Because I knew all of the answers. I was a quick memorizer because we learned by memorization. And I learned math facts quickly because I was good at memorization. So these things I loved. Why? Because I felt good about myself. I knew everything, right? I was getting A's on all of those tests. Do you know who did not like those? It was a little boy sitting next to me. I recall very specifically when we would get out the flashcards and when we get out those time tests, he would just slump in his seat. Why is that? Because he did not know the math facts. It just reminds them of what they do not know. There is nothing in a worksheet, in a time test, or in a flashcard that is going to help the child get to that answer. In fact, most of the time, students begin to shut down during these type of activities, reducing their ability to learn. Dr. Cotter writes, the only person who likes flashcards is the person like me who doesn't need them. For those who do need practice, a missed flashcard is a reminder of what they do not know. An unintended and unfortunate outcome of flashcards and time tests is math anxiety. Rote learning does have its place in learning, but mastering arithmetic facts is not one of them. A visual image, such as the Cotter abacus, I put that in there, is more permanent. It needs less review to maintain, and it can be a springboard for related facts. Now, I can hear you saying, I know it, I know you're saying this because I've heard it 100 times, but isn't memorizing math facts important? Dr. Cotter quotes in her book, Dr. Jo Boaler. She is a mathematics professor at Stanford, and this is what she says. Get this, she's a math professor. I have never committed math facts to memory, although I can quickly produce any math fact, as I have good number sense and I have learned good ways to think about number combinations. My lack of memorization has never held me back at any time or at any place in my life. Notice she says that she has learned good ways to what? Think about number combinations. And RightStart Math teaches children to think about number combinations by teaching them strategies. We already took a look at the abacus as a strategy, a visual strategy. But Dr. Cotter also in her book introduces other ways to think about strategies using the abacus to start, but then also learning how to think about numbers. Two addition strategies that RightStart Math introduces, or Dr. Cotter introduces in her book, is complete the 10 and the 2-5 strategies. These strategies help students learn facts and get to the facts they don't know through thinking, not through memorization. You know, the truth is we all forget things. I forget things. I'm pretty sure you forget things. Our children are going to forget too. However, if your child knows how to think about numbers, they can solve math facts, even if they forget them or if they have never memorized them. In addition, these strategies will help your child learn to think about reorganizing equations and numbers, preparing them for middle school and high school mathematics. Let me show you an example of the Complete the 10 strategy that's going to give you a better idea of how your child, and maybe even you, can rethink equations by working through math using, I'm going to show you the Complete the 10 strategy. So, by the way, when I introduce, I'm very dynamic in my teaching often. And so when I would teach a new strategy, specifically the Complete the 10 strategy, I would write the 9 plus 5 or whatever equation on the board, and I would bemoan it. I'm like, oh no, 9 plus 5, that seems so hard. If only that 9 were a 10, I got that one, 10 plus 5, easy, but 9, I don't know what to do with that, right? And so I create this scenario, of course, getting my kids to giggle, but then I set up the situation so that they know, okay, there's a better way. Okay, so now what we will do is have my child put 9 on the top wire, 5 on the next wire. And then I said, let's make that 9 turn to a 10, which is so much easier to solve. So I want you to put your finger on that 10 bead there. And I want you to put your other finger on that bead there. On your mark, get set, trade. And they switch places. Now, I want you to look at the abacus real quick. We have a full 10. How many do we have on this wire? We have 4, right? So what happened to our 9? It went up to 10. What happened to our 5? It went down to 4. So I used to tell my kids, the 9s go up, the 1s go down, the 1s place. Because what they ended up doing is they would see an equation with 9, and they would say, oh, better, easy way. They would look at the 9, think 10, they go to the next digit. and they'd say 1 less 4, and they get to that answer. All right, 14. So now that you understand how this process works, how this strategy works, I want you to solve this next problem. Now, don't rely on your memorized math fact. Instead, I want you to think about it. Think about reorganizing these numbers. Okay, are you ready? Do I have your attention? All right, here we go. 9 plus 7. What's the answer? Ah, 16. Did you have to count on your fingers? No. See how easy that is. The 9s go up, the 7 goes down to 6, 16. Ah, so much easier. Let's give our kids strategies to help them learn to get to those math facts quicker. All right, adding multi-digit numbers. RightStart Math teaches multi-digit addition and subtraction, by the way, by having kids experience the process. As the student experiences and understands the process, it no longer becomes an algorithm that must be memorized. Step 1, step 2, step 3, step 4. Instead, it makes sense to them. When they understand what and why, it makes sense. So they don't need to memorize it. Dr. Cotter writes in her books about, this is what she says, I know a homeschooling mom who used RightStart Math's approach. She expected her son to struggle with pencil and paper algorithm, just like she experienced as a child. However, after he worked just a few examples on the abacus, he was solving problems on paper with no additional instruction. And that is the exact case as it was with me and my kids. We worked through these activities. When they went to pencil and paper, I did not have to teach them, okay, remember to carry your 1. Nothing. They did it automatically. Now, I'm going to show you how this works. It is going to go really fast. So don't freak out if I'm going too fast. Just hit pause on your, when you watch the video, hit pause on it, watch it again, take your time. But I'm going to fly through here because of time limitations. All right, so first of all, these 2 wires, any bead on those 2 wires is going to equal 1,000. Any bead on these 2 wires is going to be worth 100. Any bead, oops, there we go. Any bead on these 2 wires is worth 10 and 1. All right, so what we're going to do is we have this equation, 3,658. We're going to input this number on the abacus. So I have a 3, and I'm going to enter 3 beads. This is 3,000, so I'm going to enter 3 beads in my 1,000 column. Here we have 600, we have 5 10s, and we have an 8. Okay, now we're ready to start adding. We're going to start with our 1s place, right? We're going to add 7 beads. There's 7 beads. We're going to squish them together. And I used to do this with my kids. Oh no, we can't have 10. And so you can see 10 here. Let me slow it down here. There's 10 beads here. We see 5 and 5 is 10, right? We can't have a 10 in the 1s place. It doesn't belong there. Where does it belong? It belongs in the 10s column. So we've got to put that 10 over there. We also call this bank, by the way, 10 $1 bills is the same as 1 $10 bill, right? So we're going to trade our 10 $1 bills for 1 $10 bill. On your mark, get set, trade. All right. Now we document how many beads do we have in the 1s place? We have 5. Did we do any trading? We did. We put a bead up in the 10s place. Okay, great. Now let's do the next place value. We have a 3. Let's add 3 beads. Do we need to trade? Nope, we only have 9 there. We have another 10th one down there. So we don't need to trade. All right, what's our answer? 9. Let's add 7 beads in our 100s place. Do we need to trade? Yes, we need to trade. We have more than 10 here. So we have to trade that 10 100 for 1,000. On your mark, get set, trade, and we document. We have 3 in our 100s place, and we did do a trade. So we mark that down. All right, now we have 2 thousands that we're adding, 2 beads into our thousands column. Do we need to trade? No. All right, what's our answer? See how this goes. This is our final answer. Now notice your child is experiencing the trading process. This is not a rule to be memorized. Remember to carry your 1, but instead it's understanding that when you have 10 in a place value, when you're adding, it goes to the next place. All right, Let's talk just a little bit about subtraction. Dr. Cotter writes, subtraction is more than the opposite of addition. Mathematicians often think of subtraction actually as adding negative numbers. Most people erroneously think of subtraction as mere facts to be memorized. However, students thinking of subtraction as related to addition will find that mastering the facts a much easier task. By the way, I underlined this because I wanted you to just recognize subtraction is related to addition. It's not the opposite of, it's related. It works with each other. All right, so let's talk about subtraction a little bit and how Dr. Cotter approaches it in the curriculum. Earlier, I mentioned the importance of partitioning. Dr. Cotter utilizes a fabulous tool that's going to help students connect addition and subtraction through the part, whole, circle sets. These sets help children see the connection between two different operations. Now, the part, whole, circle sets are also a fabulous tool to solve word problems. This is what they look like. Notice a big circle here on top, and then we have a couple part circles there on the bottom. There's the whole, bigger circles, the whole, and parts. But I only included 2 parts on this. You can have multiple parts, but for our situation here, we're only going to show 2 parts. Okay, so let's talk about partitioning 10. So here we have 10. One of the parts is 4. So 10 is our whole amount. One of our parts is 4. What is the other part? 6, right? Now, question is, are you adding or are you subtracting, or what equations can you write from this, right? We can write all of these equations. We can write 4 plus 6 is 10, 6 plus 4 is 10, 10 minus 4 is 6, and 10 minus 6 is 4. All of those equations will work. What about using part whole circles to solve word problems? Let me walk you through that. Word problems are so hard. And when you give your kids a tool to use to help them break it apart and think about it, it makes it much easier and not so overwhelming. So here is an example. Lee received 3 goldfish as a gift. Now, Lee has 7. How many did Lee have to start with? All right, that's our word problem. Let's take a look at the first sentence. Lee received 3 goldfish as a gift. All right, so what is 3? Is 3 the whole amount, or is it a part of the amount? It's a part, right? Okay, we got that one done. Now let's go to the next sentence. Now Lee has 7. Okay, let's evaluate 7. Is 7 going to be the whole amount, or is it a part? It's the whole, right? That's all he's got is 7. Okay, great. Now, how many did Lee have to start with? What is the missing part? Well, the answer is 4, right? How did you get to that answer? Did you add or did you subtract? Let's write the equations. And by the way, we can do both. I have a son in my home who thinks of every subtraction problem as addition. What do I need to add to 3 to get to 7? I need 4. So here are the equations. 3 plus 4 is 7. 4 plus 3 is 7, or we could have subtracted. 7 minus 3 is 4. The part whole circle sets are a great strategy to use to solve word problems, but it also helps them see the relationship between addition and subtraction. Dr. Cotter introduces numerous strategies throughout the curriculum and in her book, including subtraction strategies. She writes, most subtraction facts can be found by using one of several strategies. And then she introduces those strategies, the going up strategy, taking part from 10 strategy, taking all from 10 strategy. Here are several ones that she does introduce. She introduces other ones. But when the students learn to think about math and use strategies, they don't need to memorize everything. She writes, learning the facts is a hurdle for most children when it's attempted through rote memorization. Happily, strategies provide a way for children to produce the answer confidently. Dr. Cotter writes this about math facts, and I know in our elementary years, we tend to focus on math facts and we tend to focus on memorization, but there is a better way, and Dr. Cotter introduces that in her book and in the curriculum. I went through this really fast, so hopefully I didn't go too fast, but we have Dr. Cotter here. Does anybody have any questions, or I don't know who's our monitor. Did you have any questions coming in through our chat box?
This is Jeanette. I have a question. Hi. You gave an example of the complete the 10 for addition strategy. I think the other strategy you listed was 2 5s. Is that true? What is an example of that? And then can you give just simple examples for the subtraction strategies that you mentioned as well?
So I don't have a graphic, I don't think, for the 2-5 strategies, but it is absolutely beautiful. Let me see if what I've got here. Actually, I do. Hold on.
If you just want to talk about it, that's okay too.
Here's one. All right, so here is actually, let me come over to this one here. Oh, there we go. All right, so here we have, I'm going to have to do this one. 9 plus, my goodness, my computer keeps switching and moving on me. Hang on. There we go. All right, so here we have 9 plus 7. The students will enter, actually, by the way, my son who could not memorize this was his favorite strategy. What we would do is put 9 on the abacus, and here we have 9 plus 7, 9 on the abacus, and then, oh, this is 6. Oh my goodness, I have a typo. 6, but let's go with the 6 here. All right, if I were adding 9 plus 6, ignore that one. 9 plus 6, oh, that's why, this is 10. We'll just go with what this is. Let's pretend.
Yeah, I understand the complete.
What we're going to do is we're going to look at the beads. Okay, so I have 9. Let's pretend that's 9 and pretend that's 7. I'm going to see this as 2 5s. How many yellow beads do I see here? Right? I'm going to see 6 beads. So I see 1 whole 10 and 6 beads. So the big ones that my son really adapted this with. So if I were to say, what is 8 plus 7? My son is picturing 8 beads on the top wire, 7 on the second. He's seeing 3 extra, 2 extra, 15.
Okay.
That's how he's seeing it when he's doing that. Now the subtraction strategies.
Could I just say something here? There's
Oh,
another
please
way.
do.
There's another way you can do that, just using your fingers. Show 8 as 5 and 3, and just put 3 on your left finger, left hand. And 7 is 5 and 2, put 2 on your other hand. And therefore 8 and 7 is 10 and 5.
Getting the 2 5s, yeah.
That makes sense?
Yep.
Did not have any other questions in the chat, but Argenta asked, can you demo how you would teach adding negative numbers?
Well, first we have a question on subtraction.
Okay, I'm sorry. I interrupted. Go ahead.
So I was going to go to the subtraction strategies, and then Dr. Cotter, if you want to share, let me find the strategy here. But I've got to move some things out of my screen here because I've got too much on my, here they are. There we go. All right. So the going up strategy, would you like to talk a little bit about that, Dr. Cotter?
Well, okay, let's do, let's see, 10 minus 50, let's do 15 minus 9, my favorite set of. We want to start with 9 and keep track of what we need to get up to 15. So we need 1 to get to 10, okay? And then we need 5 to get to 15. So 1 and 5 is 6. So that's our answer.
Okay.
Does that make sense?
It's basically using addition for subtraction.
Yes. It's easier to add than it is to subtract. I like to say it's easier to drive around the block rather than it is to back up.
Around the block. Especially in Minnesota in the winter.
Now, taking part from 10 and taking all from 10, both of those require, to introduce it, require the abacus, as far as I know. Do you have a way of describing these, Dr. Cotter?
I'll try. Taking part from 10 is actually counting backwards. For 15 minus 9, you take 5 from the 5 and then 4 from the 10. So you're going to end up with 6. It's just like going backwards. Taking all from 10, that's really an exciting one. This time we'll use 15 minus 9. This time subtract the 9 from the 10, which gives you 1, and then add the 5. 1 and 5 is 6. And actually, during the Middle Ages, people did not learn any facts past the 10s. They did not learn the 11s or the 12s or the 13s. They simply always subtracted from the 10 and added the extra. And it really works beautifully also on column subtraction too.
One of the things that I found, so it's so funny because I told you early on in the workshop that I was a memorizer. So as I'm teaching my own kids math, I had self-discoveries during this time frame, and I evidently am a tens thinker. I think in tens, and I would do some of these strategies actually as I got older, but like the all from 10, that's how I think. And basically all from 10, I think of if I have 9 or 15 minus 9 is what the equation you mentioned. I think of, I break up the place value. So I think of 15 as 10 and 5. And I'm subtracting my 9 from this one, from the tens place, right? So I'm 10 minus 9 is 1. Now I need to add back in my ones place. So 15 is 10 and a 5. And I'm subtracting 9 from this one, which leaves 1, 5 plus 1. Does that make any sense? This is my brain on math, right? The other one is not so strong for me, but it was fascinating. I have 4 children, and it was very fascinating to me to see how each child would adopt their preferred strategies. What works for me did not necessarily work for my kids, but I kept going through the process. I kept showing the strategies that Dr. Cotter was introducing, even though it's like, well, I don't even know why I'm doing this one because everybody must think this way, right? And yet, as I was introducing these other strategies, all of a sudden lights would light up in their eyes. And I'm like, huh. Okay, that's how you think. My daughter, she is a 5s thinker. I told you I'm a 10s thinker. She's a 5s thinker. So for me, just to say the number 8, she's going 3. That's just how she thinks. She's not even worrying about the other 5. She thinks of it as 3 extras. So it was really fascinating to watch my kids think and me get to experience their growth and seeing that they all think so uniquely different.
Can
Thank
I pipe in with a quick comment as well? As somebody, we've been doing RightStart. Rachel, you and I have spoken a few times as we're kind of in and out of what we're doing with RightStart with our cooperative. So we've done RightStart with quite a bit of our kids, and I'm a huge proponent of it. But I will just say one caveat is that so much of what we're talking about, when I'm hearing it, I'm like, it makes perfect sense because we've been doing it, but to talk through it is still really difficult to listen to it. Love like, well, I'm taking this 2 and then I'm doing this 3. But when you actually start to do it and you're doing it with the abacus, it's like it becomes so clear and obvious. So don't let it get you down where you're like, I'm still not tracking these simple solutions because I think once you do it with kids and you see like you're taking the remainders, even with on your hand, it's just so quick and simple. But it's like this, like I had to kind of go through that with my children of like, oh, now I see that. And my mind was doing that, but now I can see how that works in the process. So it is so visual. And then it becomes like the mental gymnastics of all the different ways you can do it. And that's what I love about it.
Yeah, I'm tracking. I took my own kids through it and my nieces and nephews.
Cool.
But I'm just wanting a reminder about these specific strategy types. So.
Yeah. I would have one question for you guys as I am talking with other parents who are all kind of trying to come up with some different ideas for them and are considering RightStart. And, when I mention the abacus to people, one of the quick questions I get from people with the abacus is, well, they can't carry an abacus with them in their pocket all the time. Like, how are they learning? And I mean, I get that they're learning strategies. They're actually learning math and ideas. But, when you get to those bigger, longer problems that you're doing a lot of swapping, what's your response to people when they say something like that?
Well, there's two responses. One is that the children actually get that abacus in their mind. There was one boy that would actually shake his head when he was clearing his mental abacus. And a second solution is we do have an abacus app that you can put on your iPhone or your Android. So yes, you can carry it in your
You
pocket.
can carry it in your pocket now.
Right.
In addition to that, though, sometimes, I mean, obviously, we were talking math facts, addition, and subtraction. But notice when we're using side 2 of the abacus, we were doing the addition and trading. That is not something that they're going to do for every single equation from there on out. What its goal is to talk and show and help them understand the process, not to rely on the abacus to do the process for
Exactly.
them. It's not a calculator, it's a thinking machine. It helps them learn to think. And then they don't need the abacus to solve it multi-digit addition problems because they know how it's to be done.
Right. They're understanding it at that point.
Mhm.
Yeah.
Yes, when I first developed that, I tried it out with my kindergartners in my Montessori classroom. Kindergartners, they only did it about 12 times and then they went right to paper and pencil, no instruction.
Mm.
You really don't need it very long.
Well, it's very exciting to have you on the call, and a huge kudos to you because you've really opened up a lot of options in our home and just a different way of thinking. So we really, really appreciate everything you've done to put this
Well,
together.
thank
So,
you for saying
yeah,
that.
it's a beautiful program. Yeah.
Kathleen, did you say you had something?
Yes, if I can find my mute button. Did we talk about the adding negative numbers yet?
No, we haven't. Actually,
Okay.
that is one time when I like to use the number line. Normally, I'm against number lines, but a number line, it works beautifully. Also, there's something called the Cotter sum line, and it works for that also. And that's in the back of the math card games book.
And it's also discussed in the Start Math Right book.
Oh, okay. I'm beginning to forget what's in that book.
All right. Well, if we don't have any other questions, let me get to my closing slide here.
I have a question. Sorry.
Oh, that's okay.
You are using something digital to put the part whole circles and the abacus. What is that tool? As a tutor, I think that would be so helpful.
A digital, we don't have a digital tool. You
Well,
mean these?
yeah. So when you're filling in the numbers digitally so that we can see them, what are you using?
Oh, this is just simply a PowerPoint presentation.
Okay.
Yeah. Yeah. So, but I do believe that there are there's software out there. I'm thinking Google Classroom is one, but I'd have to do some more exploration. But I do know that there is software out there where you can ask a question and the students can reply and fill in either the numbers or words or whatever. I don't have that software. This is like created PowerPoint presentation. So, but if you want like feedback, one of the things that I liked, I didn't actually do this, but I actually printed out the part whole circle set and then laminated it and then used dry erase markers so that I can work with my child. Obviously, if you're online, that's not going to work. But if you were working one-on-one with them, you can write and then erase, right? So that's another good approach too.
I'm wanting to offer, times live, but also times on Zoom, and I'm seeing these. So you created this in PowerPoint. You just created the part whole circles. Okay.
Yeah,
Okay.
I do the same thing. Yeah.
Okay. All right. There's not like a software that can be downloaded specific to RightStart?
Not yet.
Okay.
But great idea.
Yes. Okay, thanks.
Thank you. Great questions. Thank you so much for taking your time out and visiting with me, and I hope you have a phenomenal day. Take care.